All right, well, happy Monday. So we are cruising here. We are mid-October now. So we've gotten to project 1 is due. A couple of people contacted me. Just if you can't get it all done, that happens. Just get in what you can for partial credit. Focus on the rubric. At least attempt the things in the rubric. So I can give you something like, oh, you tried, even if it's just you completely made it up. At least somebody like, oh, sure, here's half a point because you tried, or something. I try. And really, that's a nice way to sort of do that functional decomposition, my favorite buzzword here, because we're going to break things down into smaller and smaller and smaller steps. Be like, okay, here's one small piece. Here's that piece in the rubric. Okay, here's another small piece. Here's another small piece. So we'll talk about project 2 today as well, and then we'll get into talking about strings. So we got strings for today and Wednesday, and then next week lists and dictionaries. And our midterm's a little bit later on because I wanted to get through a little bit more of the content. Here, this is like the bulk of it, and then really like classes and exceptions and files, this is a little bit more advanced. So we're getting through like all the basics, and then we'll do our midterm. That's your little check-in, make sure things are going well for you here. I'll give you last year's midterm because I have to rewrite them every year. Not that you folks would do it, but some people post those things online, which they're not supposed to, because that's a violation of our academic integrity policy and all sorts of issues. And I don't like doing paperwork. You probably noticed, right? I'm a lazy developer. I don't like doing more work than I need to. And to get stuff taken down from websites is really obnoxious. And one reason in particular that I hate Chegg is they won't do anything without my dean signing a letter. Like, I'm not good enough. I have to get the dean involved. And that just adds more time and energy and effort to anything I have to do with them. And so, like, I'm already pissed off at Chegg. But those sorts of things. So we'll talk about the project. I've not gotten to project 0 scoring yet. I'm sorry. It was meant to happen, and it's been too busy. I will do that for you today. Should be able to get it done today for you. But hopefully you have a good sense for how you did on it, because you have the rubric, you did your self-assessment. I show you how my solution was. So at least that's how I sleep well at night. Hopefully you're not too much in the dark there. I think I've caught up pretty good on labs, getting those scored for you. Canvas thankfully gives me the to-do list, which is depressing sometimes, but we'll get there. All right, so the first thing, we're going to talk about project 1. Everyone got that in? Or as much of it in as you could? All right, cool. So we'll go to project 1, take a look at this. Let me fire up PyCharm. And only 17 is pretty good. I think we have 19 in the class, right? 19 left? I think so. It's been a little while since I looked. So we'll call this project 1. All right, and again, don't create your Git repositories. That just makes more headache than you want. Make sure it's in your repository folder. At the end of the semester, you'll feel good about it. You'll be able to figure it out. We'll do it again next semester if you continue on with me. And then pretty much every senior design group uses GitHub by now because it's actually a pretty good tool. So hopefully you'll be slightly familiar with it. And we just do some of the basics. There's more advanced features that we just don't have time to get into. But at some point we can. All right. So project 1. So building this little fake lunar lander simulator thing, just to put some sort of a story to it here. And focusing on the rubric pieces here, right? So we want to make sure we're checking all these boxes here as we go. Valid commands, tilts, self-destruct sequence, thrusters, win or lose when our distance is 0. The whole game is in a loop. So I'm going to do this whole game is in a loop last. Right? I'm going to try and tackle this piece by piece by piece. So I think the easiest thing to do is get our tilts first. Right, let's generate some random numbers first. So in our program then, we'll have an x tilt. If we want to use random numbers, we can import random. Right, now random.randint, we wanted from -10 to +10. And this is inclusive, thanks to randint. Right, it's inclusive of both ends. Great, now we got values here. I'll do the same for y. Just change that to a y tilt. So right now I've got part 1 done. Right. Hopefully that was pretty straightforward. Now we need to give them a bunch of different commands that we want to do. And we want to, if it's valid, great. And if it's not valid, tell them that it was not good, right? If it doesn't match, give them a list of valid commands. So we need to figure out, what do we want them to enter? Do we want them to enter 1, 2, 3, 4, 5, 6, 7? Do we want to have them enter something as a string? Whichever way you want to do it, it's perfectly okay. I think in this case, strings are pretty easy for this. Again, if you went with numbers, great. That's perfectly fine. I'm just going to go with strings. And we probably need to tell the user, hey, here's your distance from the surface. Here's what your tilts are. I think someone had asked me and I forgot to get back to you. I'm sorry. Or maybe I did. We should probably be showing these. If you didn't, that's okay. I didn't say you had to, but it'd be really hard to land your lander if you don't know what your tilts are. So then we'll have our distance from the surface is 10 to start off with, and then we're just going to print. We can do a little formatted print. Here's the distance from surface. Here's our distance from the surface. And maybe it's a second line then, right? Because it might get a little long otherwise. So x tilt is our x tilt, and our y tilt. I don't know, we'll do it all as separate lines. Why not? We already have 2 lines. F on the outside, y tilt, our y tilt. Okay, so print that, tell them, and then we'll ask them what command you want to send. Right? So then we'll have command is an input of what command you want to send to the lander. Okay, now we need to check and see if it's valid or not. So we probably should tell them what we're expecting here rather than make them guess. Sure, so maybe we have like a little menu, right? So sure, print enter one of the following commands. This is getting long here, but that's probably okay, right? So we'll have what I like x plus or x minus, x plus, print x minus, print y plus, oops, y plus, y minus, right? I think that's fine. You might have had different values, or anything you wanted to type out's okay. Whatever you think will be easy for them to use. So those ones are fine, and then we had thruster. So we can print thrusters, print thrusters, print self-destruct was one, print nothing, I think was another valid one, right? Because, hey, if we already centered, we shouldn't have to do anything here. Self-destruct, I think that was all of them, right? And then so that's our options here. What command do you want to send? Now this is a little bit ugly here, so wouldn't it be nice if we put a nice name to this? Again, functions were totally optional. We didn't need to do anything with functions, but I like functions, right? So I'm going to grab all of that here, and we'll make a little function here for get command. And we'll print these things out, get the command, and then it can return the command here. So then my command can equal get command. And now, if we wanted to, we could even make sure it's valid inside this list. It gets a little trickier starting to do it here. So if you're thinking too far ahead, you might run into some trouble here. So it might be nice to validate it, but we're going to have to check for that later anyway. So you don't want to have to do more work than you need to. So we get our command. We can say, hey, if command then is equal to, and we probably want that, what, lowercase, right? Dot lower, right? Just to make sure, or maybe we should lowercase it here, dot lower. That's probably even safer here. So if the command is x plus, then we want to do something here, right? Else if my command is equal to x minus, I want to do something here. Else if it's y plus and y minus, oh, the tabbing here gets really weird if I don't have something. Y plus and y minus, come on tab, there we go, y minus. Else if it's self-destruct, thrusters, right? We don't have to do them in order, but that's fine. Shift tab, thruster, self-destruct. I want to do something here. If it's nothing, that's a valid command. Otherwise, then we say that was an invalid command, right? Print invalid command, please try again, right? Sure, so we'll get a command, and then if it's one of the things we know what to do with, we do something. If not, we tell them, no, we don't know what to do with that. And for now, you can just use this word pass. I think we looked at this. Just to make Python happy, we looked at like stubbing things out. That way Python stops yelling that it's empty here. Right, so we can get the command, and we can tell them it's invalid or not here. Right. All right, cool. So we're getting close. So we checked for a valid command. Right. The self-destruct sequence, we'll come back to that one. The thrusters and commands tilt, we'll come back to that one. Win or lose when the distance is 0. I think this one might make sense to do next here because there's no loop yet. Right. Well, what happens here? So really, like all of this then happens, right, while my distance from surface does not equal 0 or is greater than 0 or anything you want to check here, right, is probably okay here. And then I can grab all this and throw it in 1. So it all belongs inside this loop as long as our distance is not 0. We'll keep on going. Now for now it should run. We're never changing distance, so we'll never stop. But for now we should just be able to run and give it some different commands here, right? So if I give it something here like x plus, it's fine. If I give it something like x plus plus, we get invalid command, please try again. And so, okay, it seems like it's checking some of these things. We could go through all of them if we wanted. That's going to take a little bit of time here. It's probably okay. All right, so those seem to make sense. I think now the tilt changing ones are probably the easiest ones to go about here, right? So if we want to increase x by, plus 1, we'll take our x tilt, plus equals 1. If we want to go minus x tilt, minus equals 1. Same with the y's, right? Y tilt, plus 1, y tilt, minus 1, okay? Thrusters then is our distance from surface. Now, this one you want to go up by 2 because valid commands should make it go down by 1. You could also just increase it by 1 and not decrease it, but I don't want to have to type things a lot here. So I think the easier thing to do here is say, hey, let me get a command and take my distance from surface, minus 1. I asked for a command, I'm going to take it down by 1. Assuming you gave me a valid command, right? And this can go up by 2, and then so the net increases 1, right? And then if it was invalid, then my little trick here is I can say my distance from surface then, undo that change. Put you back up by 1, because I took 1 away, I'm going to undo that change. Otherwise, I'd have to take 1 away for every valid command, and I don't want to have to have this thing in here 7 times, because I'm lazy, or 6 times, right? So any way you want to go about that's okay. I just happen to not want to have this multiple times, because I'm lazy. Not wrong to do it the other way. But does that little trick make sense? Right, we're just, okay. And really, the nothing can just stay here as a pass. Nothing has to happen. That's okay if they type nothing. Our distance goes down by 1. Nothing else happens. Cool. So now it should actually do something here, right? So here's our tilts. Oh, those are bad tilts here. So we want to go x plus and x plus and x plus. This is really long here. I don't really like this now. Like, that's just a lot of text here, but that's probably okay. X plus, X plus. All right, so now we need some thrusters, and go X plus some more, X plus, X plus. We need more thrusters, and then we can go Y minus, and Y minus, and Y minus, and we got to the end and nothing happened. Well, we didn't finish that part yet, right? Well, now we need the win or lose when distance is 0. So now, okay, when my loop is done, I know my distance must be 0. Right? The loop doesn't end until that happens. I don't have any breaks. I don't have any, there's nothing to finish the game here, so I don't need any fancy else's or anything here. I can just check now. So if my x tilt, now, if you like shortcuts, or if you use ChatGPT, it'll probably just say if x tilt or y tilt, right, you lose, you crashed. Remember, Python is truthy, like everything is true or false, and 0 is false. Anything other than 0 is true. So if you say x tilt or y tilt, it looks stupid, unless like you're super familiar with Python and you remember, oh, that means they're not 0. So if either of them is not 0, we crash the lander. Right, this is a silly shortcut. Right, does that, 0 is false. Does that make sense? Okay. So if they're not 0 or not 0, if either one, we crashed here. Otherwise, we print, congratulations, you landed the lander. Landed the lander, I guess it sounds silly, but okay. Did anybody watch the SpaceX thing? I didn't watch it live, but I caught a bunch of the replays here. The chopsticks. I think that's such a silly thing to call catching this ginormous thing here, but Elon is fond of silly names, I suppose. When you're rich and crazy, you can come up with all the silly names you want in the world. Sure. Turns out you can get away with a lot of things when you're rich. I don't know if you noticed that. You ever, like, speeding tickets? You can get a speeding ticket. You just pay it. So it's not really a law if you have the money to pay for it, right? You just like, oh, sure, here's $200 for speeding. I'm going to keep on speeding. Doesn't really apply to rich people. I don't know. The whole system is just a little weird. Sorry, that was a weird tangent. Oh, the SpaceX lander, that's why. It's been a lot of espresso today. It was a long day. Okay, so I think then, going back to the rubric, we win or lose when our distance is 0. Great, our thrusters and X tilt commands work. So the only thing we don't have is self-destruct, and the whole game is in a loop. Again, I'm going to leave self-destruct for another minute. So all of this then can be in another loop. Now we want these to show up. Now this same code here is here twice, and I feel bad about that, right? Would we feel bad about that? So let's turn that into a function. Not all that helpful here, but why not, right? Because we can here. So let's define get random tilt. And we can just return this, essentially. But now if you wanted to change, excuse me, your distances, or like, hey, we're going to go tilt between different values, now we only have to change it one place here, right? Sure, that's fun now. Okay, distance from surface, so then all of this then is going to go into another loop. So we're going to have a play again. Now, I like this just being starts at y here, and we can say while play again is equal to a y. Oops, no colon there, right? Sure, as long as you want to keep playing again here, let's do all of this. I'm just going to grab it all and tab it. And then we'll print. Do you want to play again? Or get, play again is equal to an input of do you want to play again? And again, suggest yn, and then maybe I'll lowercase it here just to check on that. I don't particularly care if you do these a lot. I'm assuming you know how to. So if you missed one here, there's no points for lowercasing your inputs here. But it's just good practice. Right? So all of this will play while play again is yes. And eventually we'll ask them yes or no. So anything other than a y, and we stop playing. If you enter a y, we'll play again. So it should work now. Everything except self-destruct should work for us here. So 9 and 2. Okay, so we're going to need the thrusters once. Thrusters. Invalid command. Oh, I spelled it wrong. Thrusters. That's all right. Spelling's hard. Okay, now our distance is 11. So now we can get where we need to. So y minus, x 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 minus. Congratulations, we landed the lander. Do we want to play again? Yes. Okay, now let's try and crash the thing, right? We just do nothing a bunch of times. Nothing, 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 nothing. Hey, we crashed. Go figure, right? Because our tilts weren't 0. So we've checked. Both things seem to work for us okay here. All right, and then the last bit here then is our self-destruct. The only thing it lets you do is just bluff. Like, hey, we say self-destruct, and now the only thing we're going to let you do is cancel. And not super interesting, but that's what they always did in Star Trek. So if they enter self-destruct, then we say, I don't know, we'll print self-destruct, struct sequence activated, and then we can ask for an input here. So they, I don't know, cancel code is an input of, please enter cancellation code. Cancellation code. Is there two L's? I thought there were 2 L's, but then it looked funny. And this can be, I don't know, maybe we start cancel code. Here is nothing, and then while my cancel code does not equal, what should our cancel code be? Cancel? Well, it does not equal cancel. We'll just keep on asking them to do it here. And once they've canceled it, then we'll print self-destruct sequence canceled. Or deactivated, that sounds funnier, right? Deactivated. Okay. So, little loop here. The only thing it does is ask them to enter the code. You didn't have to tell them the code. Someone was like, how are they going to know what the code is? It's just silly like that. Doesn't have to make a lot of sense. So now I should be able to say self-destruct here, and anything other than cancel here, right? And I go back to my regularly scheduled programming. My distance has gone down by 1. I wasted everybody's time here. And we bluffed the bad guys who boarded our ship. Said, you won't take the ship alive. We'd rather blow it up. And then, of course, they leave and let us go. I don't know how that always worked in the show, but apparently TV land works different than the real world. All right, so self-destruct is good. We got our tilts. We got valid commands. We've got thrusters and axis tilts. We got our win and lose when our distance is 0, and the whole thing is in a loop and plays again. I think we got it done here. That sound pretty good? And again, I used some functions just for fun. Didn't have to use any functions here if you didn't want to. Just those two seemed like, sure, put a nice name to it. Okay? All right, let me get that committed here. How'd that go for everybody? I think someone had said the projects were easier than the labs. Is that still the case? I can make the projects harder. No? Okay. This one was okay.
The first one was easy.
You had to start easy, right? All right. Cool. So we got that one done. So now we're going to move on to strings and project 2. Okay. So we're going to talk about strings in the Zybooks here. It's 1%. So someone is ahead. Thank you. Good job. I've been told, and there's research to back it up here. I just don't have the articles. I could ask one of our librarian friends to do that. That if you read the textbook, you do better in the class. That's the pro tip for you today. As someone who has graduated from college, who may or may not have read the textbook, reading helps you do better. Okay, and reading ahead of time means you'll get more out of lecture time because the things I'm saying don't sound like gibberish because you've heard them. At least have skimmed through it once here. So if you're so inclined and have the time, because of course you have all the free time in the world, right? You don't have other classes or other lives. If you read a little bit ahead of time, you'll get more out of our time together here. And then still surprisingly low on the Zylabs. I promise they don't get faster. Okay, you need to put the time into the Zylabs because they're not going to get any quicker, right? You might be slightly better at them at the end of the semester than at the beginning of the semester, but they're still tedious. Like they're designed to be tedious, and they will check every single space and comma is in the right spot here, because attention to detail is important, right? And they're checking your attention to detail, so I don't have to in the projects, which is nice. I just care if the project works. They care if you got the detail right. Like with this auto grading stuff, you wouldn't be able to pick whatever menu you wanted. It would only work if your menu looked exactly like my menu. And I think that's terribly dull here. Because I like when you folks get to design things the way you want here. But Zybooks does not. Zybooks says you do it their way or get out. All right. So we're going to talk about strings. There's a bunch of cool things we can do with strings. Doesn't seem like there's a lot here, but I promise there's a lot with strings, okay? So we'll talk some today on strings, and then we can talk about the next project, right? And then we'll come back on Wednesday and finish up the strings, right? The advanced string formatting. We've already spent some time doing some string formatting with our F strings. You can do some crazy things with string formatting, though. I don't find this particularly useful because most people don't really use programs that spit text out on the screen. Now, some people do, and they're very good for those particular things and those particular use cases. But most of the time, we're not going to need to get some really pretty looking output here for this specific thing here. So trying to do things that are like specific widths of your of a size, so it lines like this looks super pretty, right? Much nicer than any output I've ever done, and it looks nice. But again, it's of limited use here. But yeah, you can do field width. You can give it all sorts of details here. New line characters. You can specifically align things with your alignment character to do left aligned or right aligned or centered. So like passing in your left or right or center, it's really neat. You can do these sorts of things here. So, hey, I'm going to align it here and start replacing these things here, right? Like, sure, okay, so left align or right align. It's really cool, good stuff. You can fill. So we liked doing zero fills, like when we did like the clock. What does a 24-hour clock look like? We had to fill with zeros. So you say, hey, here's my zero character. I want to fill. Right, up to 4, sure. If you don't, otherwise, things you can align this way if you want. If you don't give it any size, right, then the outputs don't line up. So you can be very particular about it here as you go. And then the floating point precision, the rounding here, is probably the most useful for us when we round things, usually like to 2 decimal places, because that's pretty much as far as we care to go. If you need to be more precise, just add some more decimal places as you go. Just be aware it does round, right? It's not truncating, it's rounding. So it might look a little different here. Like if you give it 2.9999999 and want to round, it's going to round for you, right? So if you're a gas station charging $2.99 and 9/10 of a cent of a gallon, I don't know who came up with that and why they still do that. But human psychology is really weird. And we look at that, we're like, hey, it's a penny cheaper. I'm super happy now. There's a big psychological barrier there, I don't know, with nines and versus zeros. people are weird. So all sorts of advanced formatting. I'm never going to ask you to do this stuff. Zybooks will. But interesting stuff. So the string slicing is probably the hardest bit here, where we spend the most time on. The idea with string slicing is we can take a slice or a piece of a string and do something with it. Remember, strings are a sequence type, and we use indexes here to get, here's the particular character out. Well, you can do more than just that. So let me start up a new project here for, this is chapter 7, right? Yeah, there we go, chapter 7. Chapter 7, strings. I don't need the tip today. So name is, I can't spell, it's not even spelling my own name, that's just spelling name. The little 3-year-old boy who's staying with us right now, he's super really cute. We went to Bronner's over the weekend, and you can get like your name put on the ornaments. We're like, hey, do you know how to spell your name? He's like, yeah. His name's Timmy. He says, B-L-I-P-P-I. Like, okay, kid, you might be watching too much YouTube. But if you haven't had the fun of watching Blippi, you're really missing out. He'll get in the back of your head, and you'll have Blippi stuck in your head all day long. All right, anyway, so name is Eric. So if I want to grab multiple characters here, what I'm going to do, I'll say, hey, first name is equal to name. So instead of index for a single character, I'll say, where do I want to start? Where's the first index here? Well, I want to start at 0 because I want my first name here. And where do I want to end? Exclusive. Again, knowing whether or not it's inclusive or exclusive is really obnoxious here, but this one is exclusive. So what's the last index beyond where I want to stop? Well, this is 0, this is 1, this is 2, this is 3, so I want to stop at 4. So right, go up to 4, but don't grab 4. So 0:4 says grab a slice of the string from index 0 up to index 4, but not including 4 here. And I can print first name. And we get Eric. We grabbed the first 4 characters. So we can slice the string, grab a substring of it. You might hear it in other languages here. Right, so then last name, last name, name. So where do I want to start? Now, start is where it starts, which kind of makes sense because if you want to start at 0, you just give it 0, and you don't have to tell it -1. Right? I don't know. It's weird that this one is inclusive and this one is exclusive. Eventually, you just get used to it here. So we know this is index 4. I don't want the space, so I want to start at index 5, right? So 5:. Now, I could count how many characters are in Chernesky here. I know there's 9 letters, so 9 plus 5 would probably tell me where I want to stop here. Right? Is that 14? That should work here. Oh, I didn't print last name. Oops, print last name. Last name, there we go. All right, so I got that here. If I said 15, because I can't math here, it works. It doesn't crash on me. Like a list, if you try and give it, hey, I want index 15, crashes on you. String slicing doesn't, which is super weird here. But you know, it's kind of silly to do that here. So you can actually give it a default if you don't give it a value. Like when you range, you can give it, hey, I want a ending number, or I want a starting number and an ending number, or I want a starting number and an ending number and the stepping count. Remember, you can give defaults to these functions. These aren't really functions, but they also have defaults, right? So we can default in, if you don't tell it, it will give you the last index as a default here. If you don't specify, you get the last index, right? So instead of just putting like 100 here, because I know there's not going to be 100 characters in my name, I could just not start it here. It's great, okay, start at 5. Now the other fun thing you can do is if you don't give it a start value, right? So if you don't specify start, you get I guess you get 0. The start index is 0, right? So you can give it optional values here. Now, you might not know where the space is, right? Because maybe I asked them to enter their name and I want to split that into 2 pieces here, right? So maybe we'll ask them to enter their name instead. So we'll say input of enter your name, your full name, or maybe first and last, right? Because you might have a middle name, first and last name. So if I don't know where the space is going to be, I can go find where the space is. Now, this is really cool. So one of the fun things we can do when we slice, where is it giving us in here? That's stride. Oh, it's not in this one here. That's all right. We'll go find it here. So we can say name.find, and I want to find a space. So here's the index of space. is name.find the space. So when I find, if I hover over that, it gives me some optional parameters as well. So all these things, when you deal with strings, have optional parameters. It returns the lowest index in S, that's the string here, where the substring S, or where the substring sub is found, such that the sub is contained within S start to end. Optional arguments start and end are interpreted as in slice notation. So it's telling us, hey, I will go find this substring here and give you the index, the first index of where it appears here. And first is kind of important because you might have more than one space, but it's going to give you the first one here. So now when I want to split, I want to go to the index of the space here, because the space is at index 4 when I type in Eric. But then when I start, I want the index of the space plus 1, because I want to jump over that space. I don't want to include the space. Hey guys, please don't be talking in here. If you want to talk, go out of the room, please. Thank you. So anything I want to type in here then, right? If I want to type Eric Chernesky, it should find where that space is. It works out okay. If I type in something else here, let's do Jeb Sol Chernesky hyphenated, right? It finds the space and works. I can't even type my own last name. That's embarrassing. It's probably all the espresso. That's okay. It'll go find the space in here for me. Now this could be any substring. It doesn't have to be a single character. So if you want here, I could find, let's do like, how about, we'll find name. Now this isn't going to work super well, but I can say Eric name Chernesky. That worked okay for Eric, right? Because hey, where is the index where this substring starts here? This is a substring defined. Now I just said plus 1 over here. Didn't really work out well because it only missed the one character, right? Just the start of name here. But you can find multiple characters if you want to in a substring. But usually just finding one is probably pretty quick here. Now, if we wanted to find anything, and we could find the length of the thing they want to find as well, like we could say, hey, enter a sentence is an input of enter a sentence, and then a word defined to find an input of enter a word defined, and we can get the index of word defined. Find is my sentence dot find the word defined. Okay, we can give it a variable name here. Sure, and then we can print out found the word at index. We should just do a formatted string. My index of word defined. So if you give me a sentence, Eric Chernesky. Here, okay, so some sentence here. So was it the quick brown dog jumped over the lazy fox? Isn't that the one that has all the letters in the alphabet or something? I feel like it does. What word should we find in here?
Brown.
Brown, okay. So it found that at index 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Starts at index 10. We found brown. It worked. I'm sure you're surprised Python actually did what it was supposed to do. We're continually amazed when it does what it's supposed to. All right, so I can find that here. So if I wanted to like break that up into 2 pieces here then, so I could say, here's the first half then. First half, or up to the word is going to be here's a formatted string. You can throw this all in the format if you want. It gets a little messy here, but that's okay. Here's the sentence. Sliced, starting at the beginning, up to the index of the word defined. Right? Great. That should slice perfectly. Here's the first part up to that word we're going to find here. Let me end the quote. Why did that not end? Oh, curly brace. There we go. Okay, and then after the word, this one is a little bit trickier here. So after the word is going to be my sentence, starting at the index of the word defined, plus the length of the word defined. Right? Plus 1. So if I want to find brown, I'm getting the length of brown is 5. I know it starts at 10, so it should be 15. Plus 1 more because I want to jump over. I guess we don't need to, I guess we can leave the space in, right? They might not necessarily have a space. So the plus 1 was to get the space out. This should just get out brown, so we'll start with space dog jumped over the lazy fox. A space dog.
Does it count the spaces? Or?
So yeah, spaces count as characters in a string. Yep. So we skipped it when we did name because I wanted to get rid of the space. But for this one, we'll let them split on whatever they want here, right? So let's give that a run here. Let's try it. Quick brown dog jumped over the lazy fox. Or is it the fox jumped over the dog? Maybe I got it backwards here. I feel like foxes should be quicker than dogs. I don't know. All right, so let's find brown here, and we get, the quick after the word. Oh, I put this on the wrong side here. So I took this as the starting index, but I didn't give it anything after that, so it gave me a single character because I didn't slice anything. There's no colon here. So what I wanted is that colon to the end here. Hey, I'm going to copy this. I don't have to type it every time. There we go. Brown, and here we go. So now we get the quick, and then space, dog jumped over the lazy fox. I think dogs probably would not like it in space. Probably would not. Okay. So we can slice. We can take any number of characters. Now, some other silly stuff you can do with slicing as well here, because why not? This is fun. Let's make the alphabet again here. Alphabet is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. It's probably got all the letters here. So if I wanted to print, let's ask for a letter here. So what index here? So we'll get an index of letter. It's going to be an int of an input, right? Because I need that as an integer if we're going to take it as an input. Enter a index number. And index number for a letter of the alphabet. Okay, and let me actually do this at the top here, because otherwise I got to run through everything else. Do this at the top here. From logging? No, I don't want any of that nonsense. All right, so what index number, what letter do you want out of the alphabet? We've done this part before, right? Getting a single letter. We didn't do slices yet, but we can get a single one.
B.
What?
B.
So that should be index 1.
Index.
Right, because 0, A is 0, so
0 is A.
I didn't print it here. Oops, so print alphabet, that would be helpful. Of the index of the letter here. Let's try that again. So print 1, we get a B. It worked. Now, what if we did some dumb things here and told it like -1? What do you think Python's going to do for us?
Is it going to go back to Z?
Why?
Z. It goes backwards. So a negative number is counting back from the end. But now, the last index is -1 because there is no -0. You can thank your math teachers for that. Right? So -1 is the end of the string here. So you can use negative indexing on strings, which gets really weird here. And then another fun thing we can do when we're slicing is you can also create a stride. So like when we arrange, you can have what is the step or the stride here. You can do the same with your slicing here. So say, hey, I want every other character, or every third character, every fourth character here. Right? So I can say, hey, let's go from there. Let's do print the alphabet index of, we'll go everything from the start to the end, and we go by 2. So let's grab every other letter here. Right, so we'll get -1, doesn't really matter. Here's every other letter in the alphabet. That's kind of fun, right? Now, what if I wanted to get alphabet, if I want to go, can I go backwards? I feel like I could go backwards with this here. So if we do -2, maybe -2 is going to crash. Oh, -2 worked. Look at that. Backwards striding. Counting backwards. Now, weirdly, though, it starts at the end, right? So of 0, so it didn't go back 2, right? It gave me the last character, and then -2, -2, -2. So here's the other letters all in between here. So we can do some fun things with our strides. So you can really scramble some words up if you want to by doing some strides. We're actually going to do that for our lab exercise, because scrambling up strings, it's not encryption. Encryption is a whole other ball game here. Did I ever tell you the first rule of encryption? So they teach you in school, and when you get into learning how to do encryption, the first rule of encryption is don't write your own encryption. There's literally like teams of people with PhDs doing encryption work and like checking each other's work and making sure that it's actually encryption and it can't be broken. We're not going to do better than they are, right? We're just not. If that's what you want to do for your PhD, like that's the thing you want to research is encryption, go for it. Then you got a shot at it. The rest of us, we got no chance. Right? It's not going to happen. So use someone else's library that everyone else has said, yes, this is good. Okay, so we can do some striding here and slicing. That's a lot of fun. We did our formatting. Let's see, we did formatting. This is not loading. String methods and joining. So we'll work for splitting and joining on Wednesday. We'll save that one. The string methods, we've looked at a couple of them, like lower and upper. Replace is fun. You can swap out replacing something with a string with a different string here. You can do X number of occurrences. We have all sorts of optionals. Like we did find. You can find from a specific index. So, hey, I want to look starting at index 10, find the next one, find the next one, find the next one. Or you can reverse find it backwards here. Or you can count how many times does something occur in here. Now, if we, let's see, let's go back to my example here. So -1, here's first name and last name. If I don't put a space in, Eric Chernesky, and I spell it right, well, index of the space, it didn't find one. What did it give me here? Well, let me run it in debug mode here. Let me stop and run. -1, sure, Eric Chernesky. The index of the letter, or no, index of space, there we go, space. So one more, let me step over. Index of the space is -1. If it can't find something, it gives you back -1. So it can do some weird things here. When you're like, okay, let's go from the beginning to some index, and -1 is, well, 1 back from the end, right? And it's exclusive of that. That's why we lost that last letter here, right? And then if we want to go from index of the space +1, well, -1 plus 1 is 0. We get 0 at the start, no end. We get the whole string here, right? So you get some weird stuff if you don't find the values here. But essentially, if you wanted to say, hey, let's split a sentence here instead of a word defined, let's say, the index of the space then is going to be my sentence dot find this, a space, right? And while the index of the space does not equal -1, let's keep on going, right? If I didn't find one, I want to keep on going. So I'm going to print then. So here's our start index, here's 0. And we'll start at 0, so we're going to print the sentence from the start index up to the index of the space here. Okay, so I want to go from the start all the way to where I find the space here. Then I'm going to move these things. So I'm going to say my start index then is going to equal my index of the space +1. So go to the next character, next character after the space here. And then my index of the space then will be, I want to take my sentence dot find a space character starting at index, the start index. So find a space starting at this next index. Look for the next space here. If it's not -1, print out the slice of it here, of the start index up to the index of the space. So when I take this big word and take out all the spaces here, right, and give you one line at a time here. -1, Chernesky, here's name, sentence. So, oh, I did not have that in there, sorry. I thought I could copy paste the quick brown dog jumped over the lazy fox. -1, Eric Chernesky, quick brown dog jumped over the lazy fox. And we'll just find a word here. And now we get the quick brown dog jumped over the lazy, oh, we missed fox, right? Because once we had fox as our, at the end here, there was no more space to find. So the last thing we want to do then is we want to print our sentence from the start index, right? Start index up to the end, right? And this is, if there's no spaces, should also work as well, I think. Let's try that. Chernesky, some extra letters, that's fine. The quick brown dog jumped over the lazy fox. And find dog. Oh, I just misspelled that one, that's fine. So the quick brown dog jumped over the lazy fox. We got the last word here. Life looks pretty good. Does this part make a little bit of sense what we're trying to do? So because we can use the starting where, we're just going to keep looking. Okay, where's the next time it shows up? Where's the next time it shows up? Where's the next time it shows up here? So we can use some of these fun methods. Say, hey, find it this direction, starting from here. So we can jump over and find this next one, find the next one, find the next one here. Count is nice too. You can do silly things like count the number of vowels in a word. You can do those sorts of things as well. So we got to save some string stuff for Wednesday. Why don't we talk about the next project? That sound good? All right, so let's go look at the next project. Now, I like Hangman. I like silly games because I feel like it's something you can actually run. I don't know. That's what it is. So I know if you go Google Python Hangman, there's solutions out there. Right? That's not the goal here. And what I'm asking you to do here is build it very specifically with functions to practice functions and string work. Right? So the solution you find is probably not going to be written the way I want it to be written. Okay? So just don't do that. Right? Like, we want to practice our functions here. We want to practice doing some string stuff. So we're going to build a little Hangman game. We're going to get a random word that returns a random word from the word list. Let me get you that word list here. So this is what? 1,000 most common words. Most common words. Let's see. Something like this. I think I can... Oh, that's goodness. That's not... I want a list of common English words. That's really annoying to have if they're numbered. I want more than 100 though. 300? That's probably fine. All right, this is probably okay. We'll work with that. 3-letter words are hard with Hangman, but that's okay. Use code. Open code. Do a new one here. New file. Bless you. Place with comma. I think that's what I want. A space. And then, give me just a second. Sorry. I want to replace the end of the line. There we go. The comma. Why didn't it take those out? I wanted to get rid of the new lines. Leave, replace. Can I get rid of the ending lines? Goodness, I didn't do that. Okay, that's fine. I can do it this way. Really thought I could replace those. That's annoying. Just got to take out some of these, and I get you a word list here. One more. Okay, so here's the list here, and then we want to replace. I forgot to do my quotes first. Shoot. That's all right. We can replace comma space with a quote, comma space quote. That ought to get most of them for me. And then, where's my home key? Do I not have home? Goodness. All right, so here's some words. So let me start up a new project here. Project, so here's project 2. Just so you can get a random word out of a word list here. We'll make it a little bit easy. And that part's not all that super interesting here. So here's our word list. Then it's going to equal a list of, here's some words. And to get a random word out, if we import random, I can print word list dot, is it, I think it's, was it sample? Random dot, I think it's sample, the word list here. And to give it someone else? No. K. Okay, yeah, I thought it was, didn't tell me one. Sample 1. No. Sample inside the parentheses, that's why. Eventually I'll remember how these things work. There we go, this is K. So sample 1 item out here, I get, here's start. Right, so I can say here's my word is sample 1. My word, is that giving me a list though? Ugh. Word index of 0. There. And we get a random word every time we run. Saw, have, went, watch, and so on. It's going to be really hard with these 2-letter words here. It's probably okay. Don't worry too much about it here if Hangman sucks. It's not supposed to be a really fun game. That's okay. So here's a way to get a random word out. For getting a random word. So you turn that into a function to get a word back. Yeah.
Do we have to make a list, or do we have to have an empty list and then have a function that repeats over?
Yeah, so you can use this word list and return one. You just turn it into a function. So feel free to use this approach. You just don't grab one out randomly. We just need to turn that into a function is all. Yep, so you can use this one. Should we do bigger? Those words are awful. I want like Common 5-letter words? I don't know. You want better words? We want better words. List of common words. 5-letter words. Are these really words? Arg? Abaft? Abyss? Abdul? Okay, these just feel mean. Wow, that's too many. No, I wanted common ones. Those don't look common. How about this one? Okay, most frequently used 5-letter words. Okay, let's do this here. This is worth it for Hangman being better here. These will all be 5. All right, there we go. And I can replace the ending line with a quote and a comma, a space, and I can replace the starting character with a quote. Sure. Let's do it that way then. Here's our word list. All right. Now we have some better words here. I didn't put all in one line. I don't. Said, look, I wrote 100 lines of code. We're super busy today. All right. This makes me a little happier here, so I'll commit that one for you. Let me just do this project one for a start. Here's the word list. Word list. Okay, and here's more strings. Oh, I gotta commit. There we go. And push. Okay. So now we have a better word list. So now we're gonna write some functions, right? Lots of specific functions here. The idea is that this, oh, it's not very pretty here. It's a little small, but we'll say, okay, I can pretty much play the game with this here, and all we have to do is fill in the blanks on the functions. We've done some of that functional decomposition. Again, I want you to practice writing functions and playing with strings, doing specific things here. So we're going to say, okay, here's the letters I've guessed. It's empty so far. The hidden word is get a random word. Okay, number of incorrect guesses is 0. While not has the word been guessed, given the hidden word and the letters guessed, and not has the person been hanged, number of incorrect guesses. So we're going to write some functions that do certain things. We're returning true or false here. It has the person been hanged. Has the word been guessed? Returns a true or false. Right? We'll display the hidden word. Here's the hidden word, and here's the letters guessed. You have to display blank spaces if you haven't guessed the letter, and the letter if you've guessed the letter. Right? That's how Hangman works. And then we go get a guess here. So get the letter guess. Given the letters guessed. You can't guess the same letter more than once. So I'm going to give you all the letters you've guessed. So if you already guessed that letter, we tell you, no, guess again. Pick a different letter. Right? And then if guess is not in the hidden word, our number of incorrect guesses goes up by 1, and then we print the gallows. Here's the number of incorrect guesses. So, or the gallows prints out with different number of body parts, starts off empty, and then for some reason you just have a head, and then a head in the body, a head in an arm. This is a really weird game for children to play, hanging people, but I guess that's what we do. So let me go back to zoom back out. So our function get random word returns the random word from the word list. Display hidden word. It doesn't return anything here. It's just going to print something out, right? Not all functions have to return anything. It's just going to print on a single line here, blank if you haven't guessed it, or the letter if you have guessed it. Get letter guess, given the letters guessed. So don't allow them to guess when they've already guessed. And then make sure it's just a single letter as well, right? Or if you're trying to do like this find thing or however you want to approach it here, you can use multiple letters. It's just going to make it really weird. So make sure it's a single letter and make sure they haven't guessed it yet. Return that letter. And then has the word been guessed, given the hidden word and the letters guessed. Now remember, they're not going to be in the same order necessarily. Most people don't guess the letters in the order that they appear when they play Hangman, right? So how do we know if we've guessed the word or not? Right? We're going to write a function that's going to return true if they've guessed it, false if they haven't, right? Print the gallows. Again, not going to return anything, just prints the gallows with the correct number of body parts. And then has the person been hanged, given the number of incorrect guesses, is also true or false. We run out of guesses, essentially. So I can give you the gallows, too, if you want here. So this is when the triple quote is really nice here. So you can say in a triple quote block, this will be a literal string here. So we'll have some dashes and like a pipe hanging down and the left-hand side. I don't know how long you wanted to make this here. That's probably fine. Right? And then eventually we have a body. I'm going to give you the whole body on here because why not? There's a person, there's a body, we have like 2, right? So this should be an arm. So it lines up a little weird here, right? Because if you want the backslash, you have to give it 2 to escape it. Here's the right arm. So this will line up mostly nicely, don't worry too much about it. I think it's there. There we go, yep, and then space, And then, again, I want a backslash here for that one. So I think that'll print nice here. Yep, there we go. So here's our little hanging man here. So head, the body, left arm, left leg, right leg. Right, print them the number of times based on how many incorrect guesses you have. Right, you should print the correct number of body parts here. You're welcome to make it fancy and only do this once and like conditionally print arms all in one line. I feel like that's just really messy, and it's probably easier to just copy paste this 6 times. Once with the head, once with the head and the body, once with, totally up to you. Whatever way you want to go here. There's no points for how many lines of code you have there. So if it's 1,000 lines of code, nobody cares. If it's 100 lines of code, nobody cares. Right? You might care, but I won't care. And there's no points for it. That makes sense for the gallows? All right, so I would get the gallows in here too. All right, so this is the hangman with very specific functions here. And then we want to keep on looping, right, until they want to stop playing. We'll just, because that way you can try it again yourself over and over and over. Essentially, it should work like this, right? And then we'll have all these functions defined. So the points then, 2.5 points for 6 different things, should make a total of 15. Our projects are worth more points as we go, because you don't get to forget anything. We're still using all the things we've done before. So get random word works. This is mostly done for you. So basically some free points if you turn it into a function. Display the hidden word. Get the letters guessed. Has the word been guessed? Print the gallows. Has the person been hanged? It's not actually points for playing over and over and over again, but I figure by now that is pretty easy for you. I don't need to give points for that. That's 15 points. Does that make sense? Okay, I've had a lot of espresso. I'm sorry, I'm talking a little quick. But, does that sound good? All right. It's good enough for now. We'll go to the lab at 2. We'll practice some string stuff. And then on Wednesday, we'll finish up the rest of our strings here. Not too much more. We'll play with some more of those methods and then do the splitting and joining, which is lots of fun as well. And I'll see you then.